So we're going to write a proof, and this is what's called a two-column proof. It's one of the most common forms of proof that you will be introduced to in geometry, and there's something to understand about this proof, or a proof like this. So you want to start off by making different statements that all lead up to what I call the proof statement. It's what you're trying to prove to be true. You will you will need to give some information, and the information will lead to that being true. All of the information that you write down, you have to have a reason that you know that it's true. There are two basic ideas on reasons. So you will be given some information. They tell you what is true at the beginning up here or in the picture. So anything that you can see from the picture that has to be true based on that picture, not on what it looks like, but what has to be true, is also included in given. So the other reason would be something if it's not given, but you can figure it out from the given. So what you can figure out will be based on theorems and definitions and things like that. So we're going to start off by writing the given statements down here, and that's the easiest step. So you write that first. QS. So QS is that line segment that goes from Q to S. So one of the endpoints is Q, the other endpoint is S. You start at Q, you go to R. I traced to R. So QS goes from here to here. Wherever the endpoints are, you just trace that out. Now that is going to be congruent to US, which starts at U, goes to S. So since these are congruent to each other, you'll mark them congruent on the picture. And the way we do that is we just mark a little tick mark. That shows that this one, it's a way of keeping track which ones are congruent to each other. You could do it with colors, but the standard way of doing it, the easiest way to do it, is just with tick marks. So we wrote this down. We know these two are this is a true statement. The reason we know it's a true statement is because it was given to us up here at top. So you write down given. So anything given to you, that's the reason. The next thing, so you look to one semicolon, that's one piece of information. There's another piece of information, side ST, congruent to SR, and that was given to us, so that's what we write down. So like we did before, we start at S, we go to T, that identifies the side we're talking about. So now we mark it. We can't use a single tick mark because that would confuse it with this one. We want to be able to keep track of it. So we're going to use two. SR starts at S, goes to R. These are the two that are congruent based on what was told to us. Now, as you're doing this, keep track of what they are. So what we have is one side pair here. So mark it with S and an S, and another side pair here. Now remember, what we're trying to do is we're going to be using one of the triangle congruence theorems. Side, 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 angle, side, angle, side, angle, or angle, angle, side, which is the same as side, angle, angle. So it's going to be one of those. HL won't be used here. That's only with right triangles. So it's going to be one of these four. Now notice we have two side pairs. So we need either another side or another angle. They don't have any more information up here about that, so we have to figure that out. We have to figure out what we can call congruent before we use this. This will always be the last thing we do. Okay, so the first thing we want to do is we start out with the given. Then the second thing we do is things that we have to figure out. Now, whenever you see a picture like this with an X, I guess you can't see that. Whenever you see something like this, the first thing you should think of, even before you start the problem, you should be thinking to yourself, I'm probably going to need to use that vertical angles. Okay, vertical angles are the angles that are across from each other. That's the vertex. That's why it's called, it has, the vertical refers to not straight up and down, but the vertex. So the angles across from each other that share the same vertex. So these two are vertical angles. That's a vertical angle pair. And also these two are vertical angles. Now on this pair of triangles, the angles we're looking at are these two. So we can look at this and we can figure out, because we know these are vertical angles, we can figure out that these two angles have to be congruent. That's the vertical angle theorem. So we know that this angle right here and this angle are congruent. So that's another angle pair. So what we have now is side, angle, side. That's going to be enough for this one right here. But you have to make sure you have everything written down. At this point, we have two pairs of sides. We need to make sure we also include the angles, and so we have to name these. So from the picture, we should be able to get this. Now, because these two angles share a vertex, we have to name it with more than one letter. So start at one of the outside points, Q, S, R. That'll be one. You use the angle symbol. So just like that, angle, Q, S, R. Notice that's the angle that goes there. S is in the middle, which is where the bend is, the vertex. So QSR. The other side will also have an S in the middle, but it doesn't start at Q, it starts at T or U. So we go, that's going to be congruent to angle T, S, U. Like that. So just like the other ones, when we make a statement like this, we have to have a reason to be able to say how we know it. Now, if it was just copied down up here, we're going to be writing down given. If it's not up here, that means we figured it out somehow. And if we had to figure it out, then we need some reason, and that in this case, that reason is going to be vertical angles. So that's what you'll write as your reason, the vertical angle theorem. Okay, so that's SSA, but be very careful. Don't use this as the order. You have to go back to the picture to make sure you have the correct order. This is just a check to make sure you have all of the parts. So we have two side pairs and an angle. But up here is where you get the actual order. Side, angle, side. And that's the last thing we do. Now that we have everything we need here, we can write our proof statement. Triangle STU congruent to triangle SRQ. And the reason that we can say that is side, angle, side, SAS.